Howdy, this is my presentation on biofuel, and I'll be talking about microalgae biodiesel. Biofuels are renewable sources of energy that aim to reduce dependence on fossil fuels and lower greenhouse gas emissions. Microalgae biodiesel is a promising alternative due to its high oil yield and the ability to grow in non arable land. Microalgae are a more suitable option because they grow rapidly and absorb carbon dioxide during photosynthesis. The biological source and cultivation of microalgae. They are tiny organisms in freshwater and marine environments. They can be cultivated in open pond systems or closed photobioreactors. They require sunlight, carbon dioxide, and water containing nitrogen and phosphorus. Species like chlorella, nanochloropsis, and spirulina have high lipid contents, so they are often targeted for biofuel production. The production process of microalgae biodiesel starts with photosynthesis, and then it goes through a process called transesterification. This process involves harvesting, drying, lipid extraction, and chemical conversion of microalgae to biodiesel. The implementation status of microalgae biodiesel currently is in the research and development stage. Some pilot projects have successfully demonstrated its use in vehicles, but unfortunately, large scale commercial production is limited due to cost constraints. The carbon footprint impact of microalgae as a biofuel could significantly reduce carbon footprints of the transportation and energy sectors. It produces up to 70% fewer greenhouse gas emissions and has a higher energy yield per acre than traditional biofuels used today. It utilizes waste carbon dioxide emissions from power plants for cultivation as well. The economic impact of microalgae as a biofuel has a potential of a high value energy source, especially for the aviation fuel and marine transport departments. It can produce high value byproducts like protein supplements, antioxidants, and pigments, which could help offset production costs. The public communication impact of microalgae as a biofuel. The public understanding of microalgae biofuel is still limited, and efforts to educate consumers and industry stakeholders are crucial for widespread adoption. Governments are exploring subsidies and tax incentives to encourage investments in algae based fuels, and as microalgae biofuel is carbon neutral, public campaigns focus its attention on microalgae's role in reducing greenhouse gas emissions and utilizing carbon dioxide waste. My analysis and recommendation is to invest in genetic engineering to improve lipid yields of biofuel, to optimize water and nutrient usage for cost effective cultivation, and to scale up research projects to test for feasibility for mass production of microalgae. A plan of action that I would take if costs were not a constraint. I would invest in large scale microalgae cultivation. This would mean having global algae farms and utilizing wastewater. I would then develop genetically modified strains with lipid contents and faster rates of production. I would invest in automated harvesting and energy efficient extraction technologies. I would construct refineries dedicated to algae biodiesel production and develop biodiesel powered public transport systems to demonstrate feasibility. I would advocate for government mandates requiring a percentage of fuels to come from algae sources and partner with universities to and research institutions to foster ongoing innovation of microalgae as a biofuel. This is my works cited page, and thank you.